got it. Share, and meetings. All right, so let's try this again. Okay, so libraries. Libraries are a thing. And shortly, we will learn how to use them. Or how to access them in App Lab. But before that, we need to learn what they are. And there are slides that go along with this lesson, and they're linked there. You can follow along. You probably won't need to reference them later. Okay, so basic idea for a library is a set of, let's see if we can find a basic definition here. I think it might be at the end. All right, a library is a group of functions, also known as procedures, which you will see procedures if you're taking the AP test or in the rubric for the AP project, the project that everyone is doing that happens to be graded for the AP test, that might be used in creating new programs. So it is a generalized set of functions that can be useful in many different programs. It's sort of like, I don't know, come up with a good, it's sort of like a mod in video games, sort of like a quality of life. That's a good example for those who know the quality of life mod for other applications or games where it's added on and it's something that simplifies things, and it's like it runs in the background and it's there to be used. We'll see if this makes more sense as we go. Okay, so App Lab does allow you to share your libraries, but again, I don't think I'm doing a good job. Can you hang off? Like, my guess is you're doing something productive, but just hang on. All right, so a library is the collection of a group of functions that are pre-made, that are universal and could be useful in multiple programs. And the key is that they are designed to be used in multiple programs. So they all need to be self-contained with their own local variables. They can't rely on other variables in the program you're making, which is fine. Okay, so in this example, they have a function called make cake and receives two parameters, tiers, flavor, and cake cost, average cake from a list of cakes. Okay, all of those are functions that would be useful in making a cake, and they all would be in a library that you would possibly call Cake Baker. Okay, it's just a collection of pre-made functions that can be useful in multiple applications. They're generalized functions. Okay, so keys are, you need to have, okay, the documentation, which they're calling documentation the entire, well, the documentation really is the explanation. And in this case, your explanation in the library is going to be comments, like, yeah, comment your code to explain what's going on. In fact, App Lab won't let you upload a library unless your functions have comments that explain what they do. Okay, so you explain what they do, what parameters they're receiving, and what will be returned if it's a return function, like we've talked about. For the most part, these are going to be functions that have or are expecting parameters. It's sort of the way that you make functions generalized. It's hard to have a function that's useful or going to return something useful if you're not sending it specific information for the case that you're using it in. Right? They are describing an API as the specifications for how a function library. It's I don't know if this is the common use for API. I suppose it's technically correct. The specifications for how the functions in the library behave or can be used. Here, they're describing APIs really like just documentation. I don't know if that's, API really is more commonly used as like a software or a portion of a software that a company provides. And this is a specific, but probably the most common definition of API. It's not the like true edge case situation, but I think we talked about this before, maybe during networks. Like if you've ever been to a website that is sort of janky and still has Google Maps in it, like how does this janky low rent website have Google Maps in it? They're using the Google Maps API. Google provides this software to be embedded into anybody's website. And that's an example of an API, application program interface. What potential problems without having to interact with it, or without, what potential problems could come up? Try to use a function without knowing what it does. Okay, so this is the point of the documentation and writing description. It's knowing how the function works. When you do upload a library in AppLab, all of the function calls will show up in the functions toolbox, but it's not, you need to know what they are, what parameter they're expecting. Like if it's expecting 2 parameters, is it going to return, is it expecting an array or a string or a number or something else as one of those parameters? If you switch them up, it's not going to work. And you need to know what it's supposed to return so you can include it into your program correctly. But of course, if you're writing it, there's one problem solved. Okay, so I think this might be the check for understanding here, which we'll talk about in a second. But they're asking, is find smallest a useful function that could go into a library and be universally useful? The answer is no, because within this function, it needs access to the variable smallest, which smallest is a variable that's part of this program code. Everything that a library function needs to be included in that function. So there'd be some sort of local variable and a return and that sort of thing, where this function called find smallest does need access to the variable called smallest in order for it to work. And so that is not going to work. I mean, this function could work fine in the program, but it wouldn't work as a generalized, universally useful function. And also, you'd want something to send back. That's sort of there's not a lot of times you'd want a library function to not return something. If you think about having a set of functions just sort of in the background waiting for you to call them, can you go ahead and, I know, but just minimize, yeah, there we go. It's not, Jesus. You think about having a set of functions that are in the background waiting to be used, they, lost my train of thought. Okay, more of the same stuff. Yeah, okay, so they need to be self-contained, and they aren't going to be functions like update screen. An update screen function is going to have all of the set texts and set screen and set colors and that sort of thing. That's not going to be a useful function. That's going to be very program specific, depending on what you're building. But a library function like find the longest word in a list, where it just receives a list as a parameter, and returns whichever string is longest, that self-contained function can be super useful and used over and over again and only have to be written once. But so if you include everything in the program, you write functions so that you only have to write that code once, and every time you call the function, you're good. So that's useful. If you have that function in a library, you don't even have to write that function every time you start a new project, every time you start a new application, because you've already written that once. Okay, so it's like a next level usefulness. Share the library, how the function works. Okay, that. Okay, name your libraries, no spaces, capitalize the first letter in this case, and which is not the case in variables or regular function, that sort of thing. And you'll see how it shows up. Just hang on, we're still doing not screen stuff. Thanks, man. Not the same as in function naming guidelines or variable naming guidelines, where we're starting with lowercase letter. And you'll see how it shows up in AppLab, how it pre-makes them. Yeah. Okay, so when you're calling it, it's the name of the library, which will start with a capital letter, dot the name of the function from that library, and then in parentheses, whatever parameter it's expecting. And like I said before, you've already been using library calls like any of the math dot whatever, in this case, math dot round. It's a built-in library in AppLab. And it uses the same dotted hierarchy method of naming things that you will see later. Okay, when we get to the project where you're writing your own library, or writing functions for your own library, we'll do more brainstorming of what could be a useful function. And I really don't know how productive the project, and not for today, but next time, creating your own library functions, it requires such a high level abstraction level of thinking to think about, and also just experience writing different programs, to think about, well, what sorts of functions would be useful in lots of different programs that, so far we're still, writing functions for the first time for a lot of you. And I don't know, we'll give it a shot. We'll see what happens. Okay, and then this is the video that we stopped temporarily, or we didn't temporarily stop it. And all right, so accessing the libraries, uploading them. We'll get to that in a second. All right, so the check for understanding, we do it together for lesson 5. I'm pretty sure it's the same as for the example. Yeah, it's still okay. So you can see here that this function definition, function update score. The function is called update score. It's asking if player is equal to player 1 points goes up by 1, but we don't have access to player 1 points. In whatever function this is in, somewhere at the top says var player 1 or var player 1 points. 1 points is something. This isn't a useful library function because the function specifically requires access to those to that score. You could have it send player 1 points as a parameter and have the output be player 1 points gets 1 situation, but either way. All right, so go ahead and hop on to lesson 6, bubble 1. And we will take a look at a few examples of libraries. And we will read and discuss with a partner together. We will all be partners. Okay, run the program, see how program runs, try different inputs, discuss questions, and what happens when the button is clicked, open the functions drawer. I guess that's what they're calling these. Click on manage libraries. All right, so just the function runs. Let's see what happens when we type in nothing and not found, and it fills everything with the code.org icon. Lovely. Let's type a name, Alaska. Click. Okay, and it's getting a bunch of things. It's getting an image, it's getting a seal and a state, and its abbreviation. Okay, so let's see what we've got here. We've got, if you go to the functions tab, you can see that we have some new, these are actual functions that are only here available because they are in the imported libraries, which again, so as we start with these basic level programs, the usefulness of various programming techniques like libraries or, a couple of the simple return functions, they're only moderately useful at this point because the programs we're writing are so simple that the designs to make them simpler don't have very far to go. And this is an example where they have given you a library which you need to be able to access. So you're going to go ahead and do this now so that you know how to do it. The settings button above toolbox, you can go to manage libraries, and you can see there is already a library called state library. And the state library is essentially just a program in AppLab that is running alongside continuously, where if we just copied that entire thing into AppLab, it would look like a regular program. And everything from, where do we start? Everything from here down on mine, I just copied the whole thing over, is that library. Okay, a function called state abbreviation, which is receiving a state name. It's using local variables for the all of the get column things and sorting those columns within the function. And I think at the top, there is no get column. There's no data block in the provided tab or the provided program code. All of that get column stuff is referenced in our library functions, and they're all local. That way, when you call this function and put a state in it, it is able to run completely. Okay, so we have state name. What's the first one? State abbreviation, skyline, which is just the set of icon or the set of image assets, and state seal sorts through everything. And you can see this sort of, all these functions would be useful, well, they would be needed in this program, but the idea of putting them in a library is like saving this program, saving those functions. It is saving these functions to be used in other programs, so you don't have to write them again. I think somewhere in there is a useful explanation. So some common paradigms in here are, you'll see a lot of times a loop that is checking for something, and if it equates to true, it will return what it's looking for. But then after the loop, you'll see another return, like in this case, not found. A lot of times it'll be like something along the lines of check, return true, and then at the bottom will say return false, which the key is return ends the function. Wherever it wherever it lands on, whenever it lands into this conditional, return will send back the result and end the function. So it only gets to this if every time through the loop, this conditional is false. So it does return something. In this case, it returns the string not found, assuming all of them are false. And down here, you saw before when I put in not a, oh, it's because I'm running, I think it's because I'm running these. Still should work. Yeah, okay, so if you type in something it can't find a state name for, anywhere where it's supposed to get a state name, okay, so it returns not found, which is what fills in there, and it returns the code.org logo for each of the different places where different images are supposed to go. You'll notice the only function from this library that doesn't take a parameter is the random state. So state abbreviations receives the state name, state skyline receives a state name, state seal receives a state name, state flag receives a state name, and the last one, random state. It's rare that you wouldn't have a parameter. In this case, it makes sense because you do have a limited set of states, and those states are gathered here by this get column block, the data set block. That works fine. Normally, if you'd have a random, pick a random item from the list, that would be something like, even though the rock, paper, scissors only had 3 different options, we wrote a return random function that would be universal for any list. So random item that receives list as a parameter and returns one of the items from that list, that's a fantastic library function. It is so generalized that it'd be useful in a ton of different scenarios. And what else are we supposed to do? I don't think we have any deliverables on this one. Yeah, look at the managed libraries. All right, so let's look at wait, what are we doing here? Is it because I added the things? Let's see what happens if I go back to version history, start over. And yeah, all right, so it didn't let me go on because I added all that extra stuff. And bubble 2, let's see what's going on here. Okay, so we have a Pig Latin machine that takes an input and flips around that string to do the Pig Latin thing. And let's see what extra function definitions we have. We have strings library. Okay, so the library that we're given here under managed library is called strings library. And we have one function that returns the first letter in the string and all but first. Okay, so these are very good, well-named functions, or they are descriptive and meaningful names. One that searches for a val, and here is an example of a function that's doing a loop, a for loop here. And if this row, which is checking for, if it's a val, if that returns, it will return, if that ends up being true, it will return true as the entire function. And if it gets through the entire length of the word and there is no val, and this return never gets fired, it will return false. So the return true end up return false. It's common. You'll see a lot to return false and have the opposite return true, depending on what you're looking for. This function split string by space. And what is it doing here? Okay, splits. Well, if you ever want to know what it's doing, look at the documentation, the comment. Okay, it splits a string into a list of words and string characters. And okay, so it's listing a explanation of the function and what the parameters are. It only has one parameter, which is string. It's expecting a string as its parameter, and the return is it's returning a list with each element containing one word. So is this temp list, temp word? String is a append item, temp list with temp word, else temp word. If string, I'm not entirely positive what's going on there. And all right, so they're all showing up here as function calls that we don't need definitions for because they are already in our library. What's that? It's not. So you're saying because it's not the one that you learned originally, it's wrong?
Yes.
Is it possible the one that you learned originally was wrong and that this one, it's not possible? That's an interesting position to start in something that is essentially folklore. I don't know if there's a academic source for Pig Latin, but it does seem something that's just passed down. So it's hard to declare one source as true, the truth, capital T. All right, so read the documentation for, we did that. Add a console log, program to call a function. Yeah, so there's that. All right, so this is going to be much more applicable when we have some sort of application to apply it to. So what did it not like? Because did I drag something out here? Oh, okay. So in order to test, or one good way to test is to just console log a statement or add a console log statement, which I think you need to do in order to continue. And instead of console logging a statement, inside the console log, you're going to call the function. Assuming I can get it in there. Really? You should be able to call a function in a console log. What is going on here? Let me refresh. Because return functions are going to return a thing, that's what you are console logging. Let's see if we can get it in there. Why will not let me? Am I doing something completely wrong? Console log. Why did that not? I should have been able to drag that in. There's something weird going on with my app lab. Let's try it up here. Console log. And call a return function. That is really strange. I should be able to put that into there. I mean, it's accepting it here. Really strange. All right, well, I suppose you can copy the text line from here in the instructions. You all have access to the instructions. Either way, when you are testing your library functions, one way to do it is to just put error line 6. Oh, I didn't get rid of this. Put your function call or your your library function call into a console.log statement and test it and see if it comes out correct. And that's something you're definitely going to do when you are writing your own console log statements or your own library functions, your own libraries. And let's see here. Okay, so again, some obvious stuff. Why is it important to use meaningful names in the functions for your library? The same reason why it's useful to use meaningful names in your own functions and in your variables and in your parameters. It's for the sake of anybody else who's looking and trying to use your code, collaborating or whatever, and for yourself in the future. Because when you come back to code that you've written a long time ago, it may be just as confusing to you as somebody else looking at it. So give yourself a chance. Use descriptive names for all of your programming elements and use comments for your functions and that sort of thing. All right, how long have we been going? So 23. I know that was a little bland and there wasn't too much there. Let's go ahead and call it there though. And we'll do lesson 7 next time. All right. So there is that. The deadline for lessons 1 through 4 is still Friday. You need to do those. And if you are missing those, now is a great time to do that. Okay. All right, so that's it for productivity for today. Or new, I should say, for new.